Good day, everybody. Today we're going to continue on in solving quadratics. Remember what the forest is. The forest is we want to know where these quadratics will land. If you're thinking about a ball or anything, kind of think about it like this. We know the graph's going to go up and back down. That's the shape of the graph. And so we want to find out these 2 points. Where is it going to land? And with those 2 points, there are coordinates. The y-coordinate is always 0, so these are also called intercepts. But the x-coordinate can change. Now, we've solved using different methods before. We've solved doing it, we've solved equations by just doing the square root of a function, and that definitely works. We've also solved quadratic equations by doing them in a calculator and finding out where those solutions are. Sometimes your solutions are non-real because your graph doesn't actually intercept the x-axis. Now, as we go through, we're going to think more about some imaginary solutions, but that will not be our main focus today. I'm glad about that with me not being here. I'm actually at the West River Math Competition. We've got algebra students, geometry students, algebra 2 students all competing to see who can take home the gold here in the West River and end up being the best mathematician, high school mathematician in the west side of the state. So we finished off the end of yesterday by realizing that our factoring methods that we used last chapter can be used to solve these quadratics. Okay, so as we look at these quadratics, we want to be able to solve them. Here was one that we did at the end of yesterday, so I'm going to take you through that. Starting with this, we had x squared plus 5x plus 6. So we wanted to factor this, and that means we needed a number that multiplied together to get 6 and added together to get 5. So we put those there. What two numbers do that? Oh, 2 times 3 is 6, and 2 plus 3 is 5. So we know that 2 and 3 will work. So we're able to rewrite this part, the left side of the equation, in its factored form. The right side is still equal to 0. Since this equation equals 0, there's only one way that that can happen. This equals 0 if either this part is 0 or this part is 0. Because in order to get 0, you have to multiply by 0. In order to get 0 through multiplication, you have to multiply by 0. So either this one's 0 or this one's 0. Since one of them is 0, we can go ahead and write that out here. Oh, I know that x plus 2 equals 0. So there's some number x where if you add 2 to it, it equals 0. And by the same token, x plus 3 equals 0. So what is x? Well, if I think, what number do I add to 2 to get 0? Oh, negative 2. What number do I add to 3 to get 0? Negative 3. So we're able to get our 2 roots using that. We factor, and then with each factor, we solve for x, because we know that that factor is supposed to equal 0. If you come over here, this went a little bit faster. We started to understand the pattern. This was x squared minus 7x plus 12 equals 0. So that means by factoring, the two values are going to be negative 3 and negative 4. So x minus 3 and x minus 4 equals 0. Since x minus 3 equals 0, x has to equal 3 because 3 minus 3 is 0. Same thing is true for here. X has to equal 4. So what does x need to be so that with that next step becomes 0? And this ended up giving us 2 coordinates. We finished off class with this one. What two numbers multiply together to get negative 5 and add together to get negative 4? If I think about the numbers that multiply to get negative 5, one has to be negative, one has to be positive. And since they add together to get negative 4, the bigger number has to be negative. And that's why we end up with x minus 5 and x plus 1 equals 0. So knowing that x minus 5 is going to equal 0, I know that x can equal 5. That will be one of my x-intercepts, where x is 5. The second one is I know that x has to equal negative 1, because negative 1 plus 1 equals 0. Now, if you're having trouble remembering that, you always want to write this. Again, you don't have to. It's a pretty easy thing to understand. You want to know what x is so that it becomes 0. But if this helps you, write it out yourself. All right? So I know that x is 5 and x is 1, but I am not done. I need to actually write out my factors. And so this is 5, 0, and negative 1, 0. So those are my two roots, my two solutions to the quadratic. All right, we've got one more example for us to go through. This one I'll take you through my thought process for it. All right. We've got x squared is equal to 6x minus 16, or x squared plus 6x minus 16 is equal to 0. So in looking at that, I know that I want to get those two factors, so I'm going to try out that x method. Two numbers that multiply together to get negative 16. Oh, they're multiplying to get negative, so one's negative and one's positive, and they're adding together to get 6. So what two numbers do that? Well, factors of 16, I'm going to write out some factors. 4 times 4. That works, but if I do negative 4 plus 4, I get 0. So that doesn't work as this solution. It doesn't combine to get 6. So 4 and 4 doesn't work. What about 8 and 2? 8 and 2. 8 times 2 is 16. And then if I think of 8 plus 2 or 8 minus 2, I get 6. So knowing that one of these numbers has to be negative, and knowing that adding them together gets us a positive number, we know the bigger number has to be positive. So we can say 8 and negative 2. Now, in looking here, I can recognize that 8 is positive, negative, or 2 is negative as the factors. So this would become x minus 2 times x plus 8. Now, quick reminder, on Friday, a few students asked me if you could write it in a different order, and the answer is yes, you can. You can put the x plus 8 first, and you can put the x minus 2 second. Doesn't matter what order you choose. But we want to know that this equals 0. Since it equals 0, one of them has to equal 0. What does x have to be for them to equal 0? Well, for the first one, x has to be 2, because 2 minus 2 is 0. For the second one, x has to be negative 8, because negative 8 plus 8 equals 0. And this gives us our two coordinates. 2, 0, and negative 8, 0. You might notice that x plus 8 knows that we're going to get negative 8 in our x coordinate. X minus 2, we're going to get a positive coordinate. That might be something that helps you out. All right. Your job is to practice this on all 9 of these problems. You've got 9 problems to go through. You should be able to get done with them if you work hard in about 20 minutes. Go ahead and pick out any one of them that you want to do to start off with. Now, there are a few that are not equal to 0, and you'll see that here in E and G. So I'm not going to do both of them with you. I'm going to do E with you. For the rest of them, I want you to do them yourselves. I want this to stay on the big screen. If you need to rewind it, that's perfectly fine, but have this on the big screen. Click the button on the bottom where it brings up the bar, and then do annotate. And I want you guys to go up to the whiteboard and write your answers just like we do whenever I'm in class. All right, let's try out E. X squared plus 9x minus equals negative 20. Well, I want this to equal 0 because if it equals 0, I can factor it, and I know that one of those factors has to equal 0. So to get this to equal 0, I need to move that over. So I'm going to add 20 to both sides. There's no other numbers like just 20. This is x squared, that's 9x. 20 I just put on the end. So I end up with x squared plus 9x plus 20 equals 0. And that's the form that we want. Now I think of the x method, what two numbers multiply together to get 20 and add together to get 9. I can think of 20 times 1. I can think of 10 times 2, and I can think of 4 times 5. I need these two numbers to add together to get 9, though. 20 plus 1 is 21. 10 plus 2 is 12. 4 plus 5 is 9. So I know exactly which one it's going to be, 4 and 5. That allows me to go ahead and write the factored form. This is something you always want to write, because the factored form isn't just useful for getting the zeros. It's also useful for other things that you'll discover in the future. So get that factored form, but then if you want to jump all the way to the answer, that's perfectly fine. You do not have to do those middle steps where x is equal to this, x is equal to this. You could just write out -4, 0 and -5, 0. I know that because x is what I'm looking for, and it's x plus 5 equals 0. The only way that you get 0 when you add 5 to a number is if that number is -5. Speaking of which, negative numbers are integers. All right. Go ahead and do all of the others yourself. There are 8 of them for you to do, and then present your answers on the board. Just do it in a typical first come, first serve fashion, just like we do in class. Once you get done with this, you are done. You can play a board game like I've got up in the front of the room, or you can do something else, but you want to get all of these actually done. Don't just sit there and wait for everybody else to get done. Try it out yourself.